Okay, number 43, we have this wild-looking integral of x minus 5 times square of x minus 1 plus 3 all over square of x minus 1 plus 2. Okay, how do we solve this? So at first, I honestly thought maybe it's integration by parts because it's a product of things. And remember, integration by parts is from the product rule. This might be some result of the product or quotient rule. That's what I thought. But then I took a step back and attempted maybe a substitution could work. Because if I let u be square root of x minus 1 plus 3 or even plus 2, then things might work out. So this is probably one of the more challenging ones in this list of integrals because this one's not as clear as to what to try. So this is what I tried first. I didn't know if it was going to work, but this is what I tried. U is square root of x minus 1 plus 2. I let it be the bottom. Okay. Now I didn't want to differentiate directly from here. So what did I do? I subtracted 2 on both sides and I squared it. Both sides. Okay. So u minus 2 quantity squared is x minus 1. And then I differentiated from here. So 2 times u minus 2 times du is dx then. Okay. So I have this in terms of u. I have dx in terms of u. I can get this in terms of u. How so? I can just add 1 on both sides, right? So u plus 1 from this definition of u plus 1 is this term now. Now, how do I get x minus 5? Well, from here, the second line, I can just subtract 4 on both sides. Okay, so now I have everything in the integrand in terms of u. If I substitute, I get this. So you can definitely pause the video to double check that this is correct for yourself, okay? Or if you're not interested in that, you can just trust me. I would recommend that you actually check, especially if you're following along to practice. Okay, so we gotta start simplifying from here. Maybe we can see the light after this. Okay, so this u minus 2 squared, what is that? Hopefully this is a basic algebra formula you remember. It's u squared minus 4u plus 4. So that plus 4 and this minus 4 would cancel. We're left with just u squared minus 4u in this very first term, okay? Now over here, I pulled the 2 out in front. That's constant, right? U plus 1 times u minus 2. Let's FOIL it. That's u squared minus u minus 2. Okay? This is actually a good sign when we have this. There's no like another substitution we can do. Or maybe there is. I didn't bother to think about it because you can just, it's going to be tedious, but you can just expand everything out and simplify and then just do power rule a bunch of times. That's what I did. Okay. So we can divide through by u first. So I chose the easy method and just divide because these are all being multiplied, right? So you can just divide through by one of the two terms up here. So I divide by the first one. That was easy. Okay, now I distributed this u minus 4 to this u squared minus u minus 2. That's this u cubed minus u squared minus 2u minus 4u squared plus 4u minus 8. Okay, combine like terms. You get u cubed minus 5u squared plus 2u plus 8. So you can see it's actually, after that substitution and cleaning the integrand up, it became a nice polynomial, which we know how to integrate, which is the power rule. So I do the power rule here to get a plus c, and then we back substitute that u definition u squared of x minus 1 plus 2. So let me zoom out a little bit. There we go. So this is my final answer right here. And again, if you ask Wolfram Alpha to differentiate this final answer, you actually do get this answer up here. Okay? So let me scroll back to here. So this is just one way to do it. I'm sure there's other substitutions you might be able to do. I didn't see it though, as when I was doing this. So I just tried something that I thought would work. And then I persisted and went through it. And you see, eventually it was super easy to integrate. Okay, so all that to say, what was the clue here? Well, you have to try something, such on a test. Unless the professor made a typo or something, it's probably integrable. So you have to try something. Otherwise, you won't get any points at all. So clearly, it's not a trig integral. Clearly, it's not a trig sub, because I don't see something squared plus something squared. That would work out nicely. Not a partial fraction decomposition problem. So you're left with two other methods. Substitution or by parts. So I went with substitution. I tried the bottom. and then it worked out. Okay, if you tried substituting like square root of x minus 1 plus 3, it might work. Your integrand in the end might look a little different, but it might work. So the tip for me is usually I like to substitute the bottom because if it is the product rule or quotient rule, usually something at the bottom is a little nicer, usually, from my experience. Okay, hopefully this was helpful. Hopefully this is a good challenge if you tried it on your own first before watching this and you got stuck. Hopefully now you have some clarity. Okay, hopefully see you in the next video as well. Bye.